Hello, this is your question 2 in June 2022 statistics paper from AS, so year 12 content. You have a hypothesis testing. So it says a manufacturer of sweets knows that 8% of the bags of sugar delivered from a supplier A will be dumped. A random sample of 35 bags of sugar is taken from supplier A, and using a suitable model, find the probability that the number of bags of sugar that are dumped is exactly 2. So the first thing we have to do is to write what model will be. We are testing 35 bags, so a fixed number of objects, and we have a probability of success. So we have two events, success and failure. They are independent, and the probability of success is 0.08. So we can say that our variable is going to be binomial 35 0.08. We need the probability of x being exactly 2. So you just go to the calculator binomial PD, so probability distribution, with x equal to n35 p 0.08, and you get the value, which is 0.24304. And I would round to let's say 4 decimal places is a good rounding for probability questions in the calculator. The second is probability of x being more than 3. Remember, in the binomial CD cumulative distribution, we have values of probabilities being smaller or equal than a certain A. So every time we have here something different than smaller or equal, we have to rewrite our question. So this is 1 minus probability of x being smaller or equal than 3 if we don't want to get the 3. So again, you go to calculator, this time cumulative binomial CD, and you find that x equals minus 3, which is 0.69397, and then this is going to be 0.306024 decimal places. Then supplier B claims that when it supplies bags of sugar, the proportion of bags that are dumped is less than 8%. Manufacturer takes a random sample of 70 bags of sugar from supplier B, and only 2 of them are dumped. Carry out a suitable test to assess supplier B's claim. You should state your hypothesis clearly, always, even they don't say it, and 10% significant level. So our hypotheses are going to be always 80 p equal to probability that we think, or we don't, so this one, and then so always with the equal, and the other one, h1, it's going to depend on the question. In this case, they say a supplier B claims that when it supplies bags of sugar, the proportion of bags are less than 8%. So our h1 in this case is going to be to test, and h1 is going to be p less than 0.08, because that's what we want to test. We are going to assume this one is true. If this one is true and this is the proportion of bags that are dumped, it means that our variable, which is the number of dumped bags, is going to be a binomial. In this case, it's not 35 anymore, it's 70. And we can assume that this is the probability, because we are assuming this one is true. We have 2 ways of doing hypothesis testing. So in method 1, we are going to check what is the probability of getting 2 or less, so the observed value or less, and we are going to see if that's smaller than the significant level. So let me show you. We are going to check probability of x being smaller or equal than 2. You do that with the calculator with this new binomial, and that's 0.07397 something else, and this is smaller than my significant level, which is 10% or 0.1. If it's smaller than the significant level, I need to reject 80. Every time I reject 80 means that I need to accept alternative hypothesis. That's h1, so accept h1. which means really that there is enough evidence to decide or to say that really the proportion of damp bags is less than 0.08 or 8%. Yeah, so this is what we're saying. If we reject this one, we accept this one, there is enough evidence to say that the proportion of bags is less than 8%. This is one method. The other method is to find the critical region. Sometimes they ask us to find the critical region and then decide. If they don't, it's up to you which method you use. So the critical region is just a set of values that are going to help us to decide if our observed value, which is this one, the 2, is in our critical region, we are going to reject this hypothesis. So to find the critical region, we are going to say probability of x being smaller than our critical value, so the first value in the critical region must be smaller than our significant level. If this binomial is in the tables, we can use the tables. They are in the formula booklet, but they are up to n50 and we have n70, so this is not in the tables. We have to use the calculator and it's a bit of trial and error where you have to try different values of a until you get the first one, such as the probability is smaller than 0.1. That first value is 2. And the probability, as we saw here, is 0.07. This is a coincidence. So the observed value is not, most of the cases, is not going to be the critical value. Yeah. The critical region is this one, and our observed value is 2, which means the observed value is in the critical region. Therefore, I have to reject H0. So our conclusion is the same either method, reject H0 and accept H1. Yeah, so that's why I say you can use either method unless they ask you to find the critical region, and then you have to use this one. Yeah, and that's all. But always remember, with hypothesis testing questions, 2 things. You have to write your hypothesis because you're going to get 1 mark for that, and you always have to write a conclusion at the end. So if you have to say if you reject H0, which means accepting H1, or accept H1, H0, and that's it. Yeah.